friends, this is Pranav from PNM branch here to explain you about lenses. So guys, before going into this topic, I want to explain a small activity. Take a candle and a magnifier lens. Look the candle to the magnifier lens. You see that the candle is too big. And how does this happen? To know about that, you must know a series of phenomena, concept and theory. So let's look at a phenomena of light. Take a bowl of water and luminous source. Consider this luminous source is emitting a light ray which is incidenting on the surface of the water. After this gets incident, this light ray bends from this path, and this phenomena of bending is called refraction. So guys, now let's go into the topic. In this topic, we are going to see three main subdivisions. Subdivision number 1, types of lenses. Subdivision number 2, terms related to lenses. Subdivision number 3, image formed by lenses. So let's look at the first subdivision, types of lenses. But before going into that, we must know what is a lens. Lens is a transparent medium with two spherically bounded surfaces. This transparent medium can be of two types, where the spherically bounded surfaces are bulged outwards. We call it as convex. When the spherically bounded surfaces are curved inwards, we call it as concave. When we draw it diagrammatically, we get the diagram of convex like this, and for concave like this. Now consider there is a luminous source on both sides. It is emitting a light ray on the lenses. After this gets incident, these light rays converge in convex, but in concave these light rays diverge. Since it converges in convex, convex mirrors are also called as convergent lens. But for concave, since it diverges, concave lenses are also called as divergent lenses. So now let's go to the second subdivision, which is the terms related to lenses. Let's consider a lens again and a concave lens. Each lens has its own central point, which is called the optical center, and this optical center is denoted by O. Each spherical surface is a part of a sphere, so it has its own center. C1 for this and C2 for this. Again C1 for this spherical surface, C2 for this spherical surface. Consider an imaginary line is passing through C1, O and C2, and again C1, O and C2. This imaginary line is called the principal axis. Take a luminous source here. Consider a parallel ray to the principal axis is getting incident on the lens. After getting incident, this ray refracts and converges and meets at a point on the principal axis called the focus. When you do it in the opposite manner, again you get another focus here, which is focus 1 since it is on the side of C1, and focus 2 since it is on the side of C2. Now let's take another parallel ray which is incident on the surface of the concave lens. After this gets incident, this ray refracts and diverges. Since it diverges, it does not meet on the principal axis. To find the focus, we are extending this line behind. This extension intersects at a point, which is the focus again. Since it is on the side of C1, we call it as F1, and do it again, like follow the steps again on the opposite side. You will get another one, which is F2, since it is on the side of C2. So what are the terms which we saw? Optical center, foci, center of curvatures, and the principal axis. Now let's go to the important part of our session today, formation of image through lenses. But before going into this chapter, we have to see the behavior of certain light rays when they are incident on the lenses. So first let's take the case of convex. Now let's look at the topic, formation of images through lenses. But before going into that, we must know the behavior of certain light rays when it is incident on the lenses. So let's take the first type of light ray, the light ray which is parallel to the principal axis. Take a principal axis again, O, C1, C2, F1, F2. Take a parallel ray which is getting incident on the lens. After this gets incident, this ray converges and intersects on the focus. So we can say any parallel ray to the principal axis, after it's refracting, it converges and meets the focus in a convex lens. So now let's go to the second type. Take a lens again, optical center, center of curvature 1, center of curvature 2, focus 1, focus 2. So now let's take a ray which is passing through the focus 1 and getting incident on the lens. After this gets incident on the lens, this ray refracts and goes parallel to the principal axis. So we can say any ray which is passing through the focus and getting incident on the lens refracts and goes parallel to the principal axis. So let's go to this third type of ray. Let's take a principal axis, optical center, focus 1, center of curvature 1, focus 2, center of curvature 2. Now take a ray which is directly incident on the optical center. This ray, after getting incident on the optical center, it goes without getting refracted. I mean, it has a straight path. So we saw three types of rays behavior when they are incident on the lenses with respect to convex. So now let's go to concave. First type of ray which is incident on concave, take a concave lens, optical center, center of curvature 2, center of curvature 1, focus 1, focus 2. Now consider a ray which is emitted towards the focus 2. This ray, after getting incident on the lens, it refracts and goes parallel to the principal axis. So we can say any ray which is emitted towards the focus gets incident on the lens and goes parallel to the principal axis. Now let's go to the second type of light ray which is incident. Center of curvature 2, focus 2, focus 1, and center of curvature 1 and the optical center. Now consider a light ray is going parallel and getting incident on the lens. This light ray, after going and getting incident on the lens, it refracts and diverges. Since it diverges, extend this light ray, you see that it meets at focus. This extension meets at focus. So any light ray which is incident on a concave lens and it diverges, this refracted ray actually seems to come from the focus. So now let's go to the third type of the light ray which is incident on the lens. Take the lens again. Take a principal axis, optical center, center of curvature 2, center of curvature, focus 2, focus 1, and center of curvature 1. Now consider a light ray which is directly emitted towards the optical center. This light ray gets incident on the optical center and moves without getting refracted. So I say that it moves in a rectilinear propagation. So we can say any light ray which is emitted towards optical center goes without refraction. And now let's go into the topic formation of images by lenses. But before going into this topic, we must know one thing. The point where the refracted rays meet, the image forms there. So let's take the case of convex. Take a convex lens with its principal axis, center of optical center, center of curvature 1, center of curvature 2, focus 1, and focus 2. Now consider an object is at the position of infinity. Infinity in the sense where the position can't be determined. So its height is also not determined. So take a few parallel rays from the body which is emitted towards these lenses. These parallel rays, after they get incident on the lenses, they refract and meet at the focus. Since these refracted rays meet at the focus, the image is formed in the focus, and the image is highly diminished, and the image nature is real and inverted. What do you mean by real? If you have a screen over here, the image can be captured by the screen. Now let's go to the second type of image formed. Again consider a convex lens with the optical center, a principal axis passing through it, center of curvature 1, focus 2, and center of curvature 2. Now consider an object is just behind C1. The edge of the object is leaving a parallel ray towards the lens. This ray converges and meets at the focus, and it moves like this. Now consider another ray from the same point which is emitted towards the optical center and joining at the intersecting the other refracted ray. This point is actually said to be the place of formation of the image. So the image is formed here. Here again the image is highly diminished, and the size of the image is a bit smaller than the object size, where the nature of the image is real and inverted. So now let's go to the third type. Take a convex lens again, have an optical center, center of curvature 1, focus 2, center of curvature 2. Now consider the object is exactly on the center of curvature 1. This object leaves a parallel ray which is incident on the lens. After this gets incident on the lens, this ray converges and cuts through the focus. Now consider another ray which is incident through the optical center. This ray goes and meets the other refracted ray at a point. So the image is formed here. This image is formed on the center of curvature 2, where the size of the image is directly equal to the size of the object, and not only that, the image is real and inverted. Now let's move this image object a bit closer. Now let's go for the fourth type. Consider a convex lens again with a principal axis, optical center, center of curvature 1, center of curvature 2, focus 1 and the focus 2. Now consider the object is just between center of curvature 1 and the focus 1. Again consider an parallel ray. This ray converges and cuts the principal axis on the focus. Consider another ray which is incident on the optical center. These two rays intersect here. So the image is formed like this. So we can say the image is enlarged where it is formed beyond C2 and it is real and inverted. Now let's go to the final type of image. Take a convex again. Principal axis, optical center, C2, C1 and as followed before, we will take other things. Okay. Now consider the object is between the optical center and the focus. Like this. A parallel ray is emitted. This refracts, cuts the focus and goes. Consider another ray which is through the optical center. Since these two go parallelly, there is no chance, these two diverge from one another. There is no chance of intersecting, so the image can't be formed. So we are extending these two rays behind. While we extend these two rays, it is formed. The intersection happens here. So the image is formed here. Since the image is formed behind, we call it as virtual image, and this image is erect. Virtual image in the sense the image is not capable of being portrayed in a screen. Now let's go to the case of concave. Okay, now take the case of concave. Take a concave lens, a principal axis, optical center, center of curvature 2, 1, focus 1 and focus 2. Consider an object at the position of infinity emitting parallel rays. These rays diverge. So now extend these rays. While you extend these rays meet at a point which is the focus, and this focus is the point where the image forms. So the nature of the image is virtual erect and it is highly diminished. The position of the image is the focus. Now let's take the second type of image formed. Principal axis, optical center, center of curvatures, focus 1, focus 2. Now consider the images between infinity and the optical center, wherever it may be, or between C1 to F1 or C1 to O. Consider it is here. It leaves a parallel ray which diverges and a ray cutting through the optical center. So now when you extend this ray, you see that the ray meets at the extension of this ray also. So the image is formed here. So again the image is virtual where it is diminished and the position is between focus 1 and the optical center. And now let's go to the activity which we saw before. Let's find the solution for the activity. Do you remember I said there's a candle and a magnifier lens. When you look through it, it seems to be bigger. So to know about it, take a candle and a magnifier lens which is convex. Consider your eyes as the screen. Since this candle is near the lens, let's consider it as since this candle is near the lens, let's consider it is between between the center of curvature and the focus. So focus 1 and center of curvature 1. Now we have center of curvature, focus 2 and center of curvature 2. Consider a parallel ray refracting and converging at a point. Now consider another ray through the optical center. These two rays meet at a point beyond the C2, where the image is too big. So while we take a screen and portray this object, it looks too big. So consider our eyes as the screen at this place. When we look at this, it looks too big, and the solution is found. Thank you.